The first postulate of Einstein's special theory relativity states that the laws of physics are identical for all objects that occupy inertial reference frames. An inertial reference frame is one that is not accelerating. A major tenet of special relativity is that clocks that are in motion will run more slowly than clocks that are at rest. The space station, rocket, and astronaut are all at rest with respect to one another. They all occupy the same inertial reference frame, and their clocks will therefore run at precisely the same rate. Rockets frequently pass by the space station, only stopping if supplies are required. Since the rockets are moving relative to our space community, their clocks will run more slowly than our own. Or will they? What I failed to mention is that our space community is orbiting the Sun at 67,000 miles per hour. The rocket that is moving right to left is moving in a direction opposite of our motion. Relative to the Sun's inertial reference frame, he is absolutely stationary. We are the ones that are moving. What if a rocket was orbiting the Sun at a velocity of 67,000 miles per hour, but in the opposite direction of our orbit? Since our speeds are identical, our clocks should run at the same rate. We each have the same velocity, but are moving in opposite directions. Our relative velocity was 134,000 miles per hour. What if we took the Sun reference out of the picture? If we had no reference, we could call ourselves at rest. When the rocket passed by at 134,000 miles per hour, special relativity would require his clock to run more slowly than ours. He could claim that he is stationary and we are the ones that are moving. How can a theory be based on relative motion when it is impossible to determine who is moving and who is stationary?